Hello, and welcome to Google Cloud Solutions On Air. Today, I'll be talking about Anthos Config Management, or ACM for short. Following my presentation, I'll be walking you through a quick labs where you will create an Anthos GKE cluster that is managed by ACM. You can also take the lab yourself at your own leisure with our special access code. This code was emailed to you, and you can also find the details in the FAQ tab. Now, if you have questions at any point of time during the presentation, just ask these questions in the Q&A panel below, or check out the FAQ tab for more guidelines. And please feel free to join the conversation using our hashtag Google Cloud Solutions. Okay, let's get started. So before we even talk about config management, let's do a quick refresher on Anthos. Anthos provides orchestration and management services for running Kubernetes clusters anywhere. Now, these clusters can be on-premises or on cloud. And by cloud, I mean these clusters can be running on GCP, on AWS, or Azure. Using Anthos, you get a consistent Kubernetes experience, which allows you to keep your environments in sync with the same Kubernetes version, operating system, runtime, and add-ons. Now, Anthos has many components to it. Anthos Service Mesh, for example, is our fully managed service mesh, which allows you to do things like cross-cluster service discovery, traffic management, tracing, monitoring, logging, etc., across your hybrid environments. Another component, and the focus of this talk, is Anthos Config Management. Now imagine you're running multiple clusters across hybrid environments. Do you manage these clusters in silos, or is there a way for you to define, automate, and enforce policies across environments to meet your standard security and compliance requirements? This is where ACM comes in. It allows you to create a common configuration across all of your infrastructure. So, very simply, you make a configuration change, and ACM evaluates the changes and rolls them out to all the clusters so that your desired state is always reflected. Now, you may ask, what exactly is so difficult about managing a hybrid footprint? Now, as deployments become complex, teams tend to add more clusters for use cases such as high availability, global coverage, multi-tenancy, edge computing, and so on. But each time you add a new cluster, that means you are adding new overhead in managing a separate set of configurations. This means you can have a lot of little clusters, and all of these clusters might be living in silos and having to be administered separately. In that case, how do you set policies to configure and maintain consistency across your deployments, across your clusters? Further, managing application lifecycle, such as automating deployments using placement policies in your CI/CD pipelines, can become extremely challenging. So this is where ACM comes in. ACM allows you to define your configuration, and you write your configurations as code. So you save your configuration files in a Git repository, and ACM synchronizes the state of your clusters against this repository. You can configure a single cluster or multiple clusters from a single Git repository. Again, at the risk of sounding repetitive, these clusters can reside on one particular platform like GCP, or it can span across a hybrid environment, for example, multiple clouds or on-premises. So this essentially means that you can apply configuration changes to hundreds of clusters using a single Git commit instead of writing scripts to run thousands of kubectl commands manually. You thus reduce the risk of shadowed ops. By shadowed ops, I mean unvetted changes which are generally pushed to live clusters, and where it becomes really difficult to understand the differences between a documented configuration and your actual live running cluster environment. So just like your typical application development, Even for configuration management, changes can be peer reviewed before they are pushed to a live environment. Now, centralized policy management can also be integrated with your CI/CD pipelines to test changes and apply them automatically when tests pass. So ACM can sit as one of the additional steps in your CI/CD pipeline, and you can validate the changes before they are made live in your production environment. Okay, so let's take a look at how policy distribution exactly works. As I mentioned, ACM takes advantage of Git's file system-like structure and uses it to determine which clusters or namespaces a configuration is relevant to. So in the diagram here, you can see a hierarchical representation of configurations that belong to either a cluster, a namespace, or the entire system. For example, if you have a configuration that is relevant only to a particular namespace, then it will find itself under the namespace folder. On the other hand, if you were to create a cluster-wide role, then the configuration will find itself under the cluster folder. Now, in a configuration, you define your requirements. For example, you may require that each namespace in your cluster should have at least one label. Now, this might be useful for setting up use cases such as GKE metering, etc. Or you may want to enforce pod security policies across deployments across your clusters. Or let's say you are starting with a fresh cluster, or even for an existing cluster, you may want to create and enforce a cluster-wide role with limited privileges for your developers or your testers, or even for your production environment. So here is a more concrete example of how a configuration file looks like. Now this is a heavily simplified version. It can be a lot more complex depending on the use cases that you have. But here you define this configuration, you check in this file in your Git repository. ACM will read this configuration and it will create a namespace called shipping prod if it does not already exist or it is not managed by ACM. Now, if someone were to manually modify any of the object's metadata which are being governed by ACM, then ACM finds that there is a drift and it resets it back to the value in the configuration. So in your Git repository, you define things like resource quota, namespaces, and access control policies like RBACs. Now these policies will have an impact across clusters. ACM is declarative. It continuously checks cluster state and applies the desired state to enforce policies. Now, ACM does this by using a custom policy controller called config management operator. I'll talk about config management operator more in the labs that follow this presentation. Okay, so you saw a very simple example, but if you'd like to go slightly deeper into what ACM can do, stay with me for the following session where I'll take you through a hands-on lab. In this lab, I'll configure Anthos Configuration Management and explore some of the features that we just talked about. I'll connect a Git repository for configuration as code change management, and then set up a config operator to manage a GKE cluster. Finally, we'll see how the operator maintains state in the cluster to match your repository. Okay, so I have covered a lot of ground in the last 10 minutes. So just to summarize, you can use ACM to roll out configurations to your clusters, ensuring that your desired state is quickly reflected and actively maintained. You can prevent pushing bad configurations with built-in validators that review every line of code for conformance before the code even makes to your repository. If you have existing definitions, you can easily migrate with native Kubernetes configuration formats such as YAML or JSON to store your multi-cluster policies. You have flexibility in configuring different policies for groups of clusters or namespaces. Now, for example, you can apply different quota levels to staging versus production resources. Prevent configuration drift using continuous monitoring for your cluster state. You can also continuously audit your Anthos environment to identify clusters that do not follow your organization's custom rules. Okay, that's it for the presentation. Thank you for joining me. For those of you who might be interested in the quick labs, please stay put. I'll be taking you through all the things that I talked about. We appreciate all the feedback, so please let us know your thoughts on this session. Just click the survey link in the Q&A panel below this video. And if you enjoyed this session and you know somebody who would also benefit from watching it, please do share it with your friends and colleagues. And please do follow us on our social channels. Join the conversation and tag us with hashtag Google Cloud Solutions on your preferred social media. Right? Once again, thank you so much for joining us. See you in Quick Labs.